humans on Mars in the 2030s.
Yeah,
It still sounds almost like science fiction, doesn't it?
it really does. That thrill is still there.
But it's a very real goal. I mean, think back to the summer of 2020.
Right.
Even with everything else going on, you had NASA, China, the UAE, all launching missions to Mars around the same time.
It really captured the world's attention, didn't it? A kind of global focus on the red planet.
Exactly. And what's so interesting now, and what we're diving into today, is how NASA's big push back to the moon with Artemis. Well, how that's directly setting the stage for Mars.
Absolutely. It's not just, going back for nostalgia's sake. It's strategic. It's preparation.
Precisely. And that's our focus for you today. We've looked at some great sources.
Mhm.
There's a NASA piece explaining how investing in the moon helps prepare for Mars. We've also got some really interesting takes on developing the moon itself from Anthrofuturism and Astrocoby over on YouTube.
Yeah, some fascinating concepts there.
And of course, updates from SpaceX, their role in lunar missions, and naturally, Starship development.
So our goal here really is to connect those dots for you. How exactly do these moon activities, the tech, the experience, the science learned, how does it all become essential for that much harder trip to Mars?
Right. We want to show you that getting back to the moon isn't just the end game. It's the critical stepping stone.
Couldn't have put it better myself. It's the foundation for becoming interplanetary.
Okay, so let's dig into the specifics. NASA talks about 5 big hazards for humans in space.
Right, the big 5.
You've got altered gravity, radiation, the hostile environment itself, isolation, and confinement.
And just being so incredibly far from Earth.
Yeah. We study these things now, of course.
Yeah.
Simulations, the ISS. So how does going to the moon help us tackle these for a Mars trip?
Well, that's the key, isn't it? The moon is days away, not hours like the ISS. So it's a much higher fidelity deep space environment. It's a more realistic testbed. Simulations and the ISS are great. They give us vital data, but the moon lets us test the actual systems and procedures, communication delays included, in conditions much closer to what a Mars crew will face.
So it's like the ultimate shakedown cruise before the really long voyage.
Exactly. Now, NASA breaks down their lunar investments for Mars into 3 main buckets.
Okay.
The first one is understanding the Martian environment.
We've sent a lot of robots there already, haven't we? Feels like we know Mars pretty well.
We do, relatively speaking. The article notes 55 attempts, 28 successful from 8 different nations.
Wow.
And yeah, they've shown us Mars might have been a Goldilocks planet once with water. Now it's cold, thin atmosphere.
Right, that atmosphere. It's mostly CO2. Curiosity found that out.
About 96% CO2, yeah, with traces of other stuff.
So that thin air, it's a challenge for landing, but maybe an opportunity too. That CO2.
Precisely. That's where MOXIA comes in, the Mars Oxygen In Situ Resource Utilization Experiment.
Right, on the Perseverance rover.
Yeah. It's actually making oxygen from the Martian atmosphere right now, testing that tech.
That's incredible. Think of the implications. Making your own air, even rocket fuel oxidizer potentially.
It's a potential game changer for mission sustainability, reduces how much you have to haul all the way from Earth.
But as you said, that same thin atmosphere makes landing, the big stuff, like human landers, really, really hard.
It does. Parachutes just aren't as effective, much less drag than Earth.
So how do we figure that out?
Well, Perseverance also carries MEDA, the Mars Environmental Dynamics Analyzer, a Spanish instrument.
Okay.
It's constantly measuring temperature, pressure, wind, radiation, dust, all the things you need to know to design better landing systems, and frankly, just to predict the weather for future astronauts.
Gotcha. Understanding the environment is step 1. So what's the second category of NASA's Win for Mars investment?
That's common Moon-Mars systems, and this is where you really see the direct link.
Okay, so technologies that work for both places.
Exactly. Artemis is the perfect place to test and refine hardware operations needed for Mars, maybe even getting us there in the 2030s.
Like those commercial robotic moon landers starting soon.
Precisely. They're planned for about twice a year, starting next year, even before the astronauts go back. They'll test landing tech, look for resources like water ice, monitor radiation, all directly relevant to Mars.
And the big hardware, the SLS rocket and Orion.
Yep. SLS is powerful enough to send Orion to the moon, but also to launch components for a Mars transit habitat into deep space.
A habitat for the trip to Mars.
Right. And the plan is really clever. Test that habitat out at the Gateway, the lunar space station, for several years first.
Ring out the bugs in lunar orbit before the big trip.
Exactly. And they're even looking at commercial cargo ships, potentially resupplying or refueling it there. It's building that deep space logistics capability.
Makes sense. What about stuff needed on the surface? Rovers, habitats?
Also designed with Mars in mind. The rovers, the spacesuits, the small habitats, the power systems developed for the moon. They're essentially prototypes for Mars systems.
So astronauts use them on the moon, give feedback.
And we learn what works, what needs improving before we send similar gear all the way to Mars. That includes crucial things like advanced life support systems for those long journeys.
Okay. And the human landing system, the HLS. The space taxi to the surface. Landing on the moon is different from Mars, right? No atmosphere versus thin atmosphere.
True, the EDL entry, descent, landing is different, but other parts are very relevant.
Like what?
Like the ascent system launching back off the surface. The mechanics are similar. And critically, storing cryogenic propellants like liquid hydrogen and oxygen for long periods without them boiling off. That's vital for Mars.
Ah, the boil-off problem.
Exactly. Plus, these new landers use advanced terrain relative navigation for pinpoint autonomous landings. You definitely need that on Mars, too, to avoid rocks and craters.
It sounds like Artemis involves more than just short visits then. That NASA article mentioned kind of dress rehearsal mission.
Yeah, this is a really key part of the plan for after the Artemis base camp is set up and Gateway is more capable.
So what does it involve?
They envision sending a 4-person crew to Gateway, 2 stay on the station, 2 go down to the lunar surface in a reusable lander.
Yeah.
And they stay there for months, simulating a Mars surface mission, living, working, doing science, collecting samples.
They got months on the moon.
Yeah. Then they rendezvous back at Gateway and return to Earth. It's about learning how humans operate effectively for long durations, far from home in that kind of hostile place. Huge learning curve.
Incredible. Okay, that covers common systems. What's the third NASA category?
Mars-specific technology development, things uniquely needed for the red planet.
What are the big ones there?
2 stand out. First, nuclear propulsion.
Faster travel times.
Exactly. Nuclear electric or nuclear thermal. NASA, the Department of Energy, industry, they're all studying this. The goal is maybe a 2-year round trip to Mars, much faster than chemical rockets.
That cuts down on radiation exposure, isolation time, all those hazards.
Precisely. The other big one is those Mars EDL systems we talked about.
Landing the really big stuff.
Yeah. Curiosity rover was about 1 metric ton. That's the biggest we've landed so far.
Okay.
Human landers, they'll need to be maybe 20 times heavier.
20 times.
So we need totally new ways to slow down and land safely in that thin Martian air. It's a massive engineering challenge.
No kidding.
Yeah.
So putting this all together, what might that first human trip to Mars actually look like?
Yeah.
Based on current NASA thinking?
Well, the article suggests the first surface stay would likely be relatively short, maybe around 30 days.
Just 30 days on Mars and next.
For the very first mission, yeah. A lot of it has to do with orbital mechanics.
Right. Earth and Mars moving around the sun. You'd have to time the trips.
Exactly. You get different mission types. Conjunction-class missions are more fuel efficient.
But longer.
Right. You might stay near Mars for over a year, waiting for the planets to align again for the trip home. Total mission could be 3 years.
Oof. Long time.
Then there are opposition-class missions, faster transit, higher energy.
So quicker trip.
Quicker round trip, maybe about 2 years total. But the stay at Mars is much shorter, like that 30, 45-day window.
And NASA's leaning towards that for the first one.
Currently, yes, because the initial surface setup will be limited. It's kind of a get in, do some key science, get out approach for the very first landing.
Makes sense. And how do they make sure the crew can actually get back home from Mars?
Pre-deployment is key. Before the crew even leaves Earth, robotic missions would land critical gear.
Like the return rocket.
Exactly.
Yeah.
The Mars Ascent Vehicle, or MAV, plus the propellant it needs. It has to be there, waiting and ready.
That sounds like a nail-biting requirement.
Absolutely critical. And you need a reliable power source on the surface before the crew arrives, too.
For the Ascent vehicle.
For the MAV, yes. And for recharging rovers, running life support tests, etc. Probably a compact nuclear fission system, like the ones being tested for Artemis on the moon.
So the moon power systems are directly paving the way.
Directly. Plus robust communications gear, also pre-landed, to keep sending data back after the crew leaves.
Wow. It's an incredibly complex dance, planned years in advance.
Decades, really.
Okay, let's shift gears a bit. That anthrofuturism video laid out a really ambitious plan for, like, building a real lunar outpost. Conceptually, of course.
Yeah, really detailed. They emphasize starting with tech that's, maybe just over the horizon.
Like what?
Mature lunar ships, think Starship, they figure in the 2030s, and those small Generation 4 nuclear reactors for power, reliable power, is step one.
Makes sense. And the first deliveries, what did they send?
Their idea was 2 initial launches carrying 2 reactors and the basic tools for, like, lunar metallurgy, a caster, press, ladle, tools, stuff to start working with lunar materials.
And they had that clever idea about the empty fuel tanks.
Yeah, use them for extra cargo space on later flights. But critically, they focused on electrolysis reactors.
To make oxygen.
Yes, for breathing air and for rocket fuel components by processing the regolith, the lunar soil, into steel and getting oxygen as a byproduct. A closed-loop system.
Very efficient. So power and basic materials first. Then what?
Deliver a machine shop, a CNC machine, 3D printer, work surfaces.
To make stuff on the moon?
Exactly, using the steel they're producing. Make tools, parts, maybe even some basic structures. Reduce reliance on Earth imports dramatically.
It sounds like true self-sufficiency taking shape.
Yeah.
And habitats, how do they build those?
Their concept was pretty practical. Dig a hole, use the locally made steel beams and maybe some imported panels to build a basic steel box.
Okay.
Add an airlock, import the initial gases, life support, wiring, though maybe some components could be 3D printed later.
And bury it.
Yeah, cover it with the excavated regolith. Natural radiation shielding. Simple, effective.
Do they talk cost? I mean, that sounds hugely expensive.
They threw out a very rough estimate, maybe in the ballpark of $5 billion over 8-10 years for that initial setup.
Still a lot, but maybe less than people think.
They compared it to, like, fighter jet programs or fractions of government budgets. They also tossed out a potential lunar tourism ticket price around $550,000 to break even, with potential for profit.
Interesting. Commercial angles again. And they had one more really big idea, right?
Oh, yeah. The giant nuclear-powered space ferry.
To travel around the solar system.
Yeah. Leveraging nuclear power and lunar manufacturing to build massive, efficient ships for cargo and people, potentially making chemical rockets obsolete for long-haul trips.
A true sci-fi vision becoming plausible.
That's the idea they put forward. Very ambitious.
Okay, now the Astro Kobe video. He was focused squarely on Artemis and the moon base. He called it completely unbelievable, like building a new country.
Yeah, his enthusiasm really came through. He broke Artemis down nicely.
Okay.
The spacecraft, SLS-Orion, plus commercial landers like Starship.
Right.
The Lunar Gateway, that orbiting station.
The space.
Exactly. And then the Artemis Base Camp itself, the permanent base on the surface.
And the landing system, that space taxi concept.
Yeah, ferrying crews between Gateway and the surface. And his vision for the base camp included those futuristic cabins, rovers, and a real focus on the South Pole.
Because of the water ice.
Water ice, yes, potentially lots of it. And also areas with near constant sunlight on crater rims, perfect for solar power farms.
And he really hammered home the idea that this whole moon base effort is the essential practice run for Mars, right?
Absolutely. Learning to live self-sufficiently, far from Earth, understanding the long-term effects of radiation and low gravity. It's all critical prep work for doing something similar, but much harder on Mars.
He also talked about the inspiration factor, like Apollo.
Yeah, bringing humanity together, inspiring the next generation. He mentioned the Earthrise photo from Apollo 8.
A classic.
And how seeing Earth from afar changed our perspective. He framed it all as our first real steps towards becoming multiplanetary. So for you listening, it's not just flags and footprints this time.
It's building a future off-world.
Exactly.
Now, we can't talk moon missions today without talking SpaceX. Their website has some good info on their role.
For sure. They state clearly they're focused on returning humans to the moon, noting how few have ever been.
Only 24 flew there, 12 walked. Nobody since 72.
Crazy when you think about it. And they echo NASA's view. The moon is invaluable experience for Mars and beyond.
They even laid out a typical Starship moon mission profile.
Yep, about 6-7 days. Launch up methane oxygen, booster SEP, translunar injection burn.
Heading towards the moon.
Lunar flyby, closest approach is Paraloon. Then head back, re-entry, landing.
And NASA picked Starship for the Artemis landings, starting with Artemis III. That's huge.
Massive vote of confidence. It'll land the crew near the South Pole for those first Artemis moonwalks, survey the base campsite.
And later, deliver cargo.
Supplies, equipment, science payloads, yeah. And they keep posting updates on Starship's testing those high-altitude hops, SN8, SN15, all part of developing that fully reusable system for Moon and Mars.
They also have private plans, right? Like Dear Moon.
Yeah, the private tourist flyby mission. That original 2023 date slipped, but it's still planned. And the Polaris program.
What's that again?
Up to 3 private human space flights. Cushing Tech, doing research. culminating in the first crewed flight of Starship.
Oh, okay.
The first one, Polaris Dawn, using a Dragon capsule, aims for a record-high Earth orbit, first commercial spacewalk, and testing those Starlink laser comms.
Which are vital for Moon-Mars comms later.
Exactly. It all connects.
It's amazing seeing government and private industry pushing together like this. And it's not just the U.S., is it? That Moon Mission Updates article showed, well, basically the whole world is getting involved.
It really has become a global effort. Over 30 countries involved now.
30?
Yeah, alone or in partnership. Crewed missions, robotic missions. You've got the U.S. with Artemis aiming for 2026 landing, sustainable presence for Mars.
China aiming for a crewed landing by 2030. Permanent base, using lunar resources.
Russia continuing Luna, maybe crewed in the 2030s. India, Japan, ESA contributing big time. UAE, South Korea, Israel, Canada with Canadarm3.
Wow, keep going.
Germany, UK, France, Italy through ESA or bilaterally. Australia building a rover for Artemis. Mexico, Brazil signing the accords. Luxembourg investing in mining. Saudi Arabia, Turkey, Ukraine, Singapore, New Zealand via Rocket Lab, Poland, Sweden, Norway, Czech Republic. It's quite a list.
It really is. It shows this huge global momentum.
Yeah.
And the article mentioned private companies beyond SpaceX, too?
Definitely. Blue Origin, others. That commercial space race is a huge driver. And the Artemis Accords provide that framework for peaceful cooperation, signed by over 30 nations now.
Okay, so let's wrap this up. It's crystal clear, isn't it? Artemis isn't just Apollo 2.0.
Not at all.
It's NASA making a very deliberate strategic investment, testing tech, understanding deep space hazards, building systems needed for both Moon and Mars.
Yeah.
All to get humans to Mars, maybe as soon as the 2030s.
And it's not just NASA. Commercial partners, international collaboration, they're all essential pieces of the puzzle.
And for you listening, it's important to remember this isn't just happening out there.
Right.
The tech developed, the science learned, even the global cooperation. It has real benefits back here on Earth. You're basically witnessing the dawn of, well, of us becoming a multiplanetary species.
It really is history in the making. Those foundations are being built on the Moon right now. It's pretty awe-inspiring when you step back and think about it.
It really is, which leaves you wondering, as we actually start living and working on the Moon, what completely unexpected things might we discover or invent? Things that not only help us get to Mars, but maybe change life here on Earth in ways we can't even guess right now. Or, what are the deeper questions about setting up shop permanently beyond Earth? Lots to think about.